What's the code testing?
I wonder what we were doing.
Okay, just hold that there for a second. Out of class.
I was wiping off the table and I went under clean the plastic under it, but there's wood up there also, so a big chunk of wood that was poking out just like scraping up.
Alright, look at what we got here. Let's get going. Shh. Let's get going. I've got, says find an equation of the line with a slope of 2 at a point of 0, negative 3. So we're asked to find an equation of a line that has a slope of 2 and a point of 0, negative 3. There's something special about that point 0, negative 3. Cute there, little girly. What is it that's special about that point 0, negative 3? Okay. Caleb's on the right road.
It's the Y-intercept.
It is indeed, Mr. Rutledge. If I look at that on the graph over 0 down 3, it's the Y-intercept. There's a symbol, and it's a weird one because it doesn't have a Y or an I for Y-intercept. Hint, hint. There's a symbol for Y-intercept in a linear equation. Ohm is slope. Y-intercept is B. Who was that? A kid, Ms. Grace. So this is our B. This is our M. All we have to do is plug those dudes in. Right with me? So we got y equals 2x plus negative 3. You just wrote an equation.
Whoa.
Woo!
Wow. Wow.
Y'all were real good. Chase was, and whichever fella over there it was that, I think it was Caleb that figured out that negative 3 was the Y-intercept. First period, I thought I was going to have to pull teeth trying to get them to realize that. So good job on that.
But you're going to full speed.
It's just an expression.
That's brutal.
Yeah, but
It's probably get tired hard today.
I guess it depends on what kid it was.
Not about for you. They deserved it.
All right, this time, everybody okay on that? So what's this where I just starred right here? Look where I'm starring. What's that called?
That's slope-intercept form.
Slope-intercept form. We're going to cover all the different forms today. So slope-intercept form is the most common. It's the one that we use the most. Okay, so put it up. Slope-intercept form. All right. Okay, now I've got an equation, and I am on a graph on this one. Caleb, maybe. This thing hasn't been up to its A game lately, has it? X. Because you were asking about graph paper.
That was mine.
My bad. Do you go by Mike and I just call you Michael?
No, I like Michael better.
Okay.
Everybody just calls me Michael. Call him Fred. Don't call him Fred.
Alright, we got x plus 2y equals negative 4. Now, we graphed, listen, we graphed this earlier in the week by plugging zeros in. This one would be a real easy one to plug zeros in. Guys, y'all be quiet. If I were going to work it on my own, that's how I would do it. But we're going to work with slope and intercepts a lot today, so that's what we're going to do. So if I'm going to graph this today, we're going to find the slope and the y-intercept. So what do we need to do to that equation they gave me to find the slope and the y-intercept?
Solve for y.
Good. Solve for y. Get it in slope-intercept form, which just means solve it for y. So right now the y has an x there that's in the way, so we're going to subtract x from both sides. Tell me, why did I write the minus x first?
Slope-intercept comes first.
Good. X comes first in slope-intercept form. So we got that. Good, good, good. Now my y is being multiplied by 2, so what should we do? Divide by 2, and that means divide everything by 2. Negative x divided by 2. What's a good way to write that?
Negative 1/2.
Hey, look at y'all. I'm going to move y'all up to my smart class. Negative 4 divided by negative 2 would be, or just divided by 2, my bad, would be a negative 2. Okay? Y'all are way better than first period.
Wow, we're smart.
I know. I don't know about them. They're struggling. Alright, so now, what's my slope? Tell me what M is. Alright, tell me what B is. Negative 2. If I got to graph this line, which one of those am I going to graph first?
The negative.
Good, Grace. Go ahead, Mason.
Negative.
Good, the -2, the y-intercept. So we're going to go down to 2 since it's a -2 and put a point.
Wait, I gotta draw.
Okay, we all right? All right, so now all I need to do is slope of -1/2. Okay, so that means I'm going to go back to the origin, and I'm going to go down 1 and left 2. Put a point.
Is B always the Y-intercept?
Yes. Is everybody all right with that? Oh, first is this first period? Then I'm going to go down 1 and left 2. Why'd y'all just draw a triangle and no line? What happened? What did I do wrong?
You went from the origin.
Ooh, okay, Lee, good job. Where am I supposed to start that slope from?
-2.
From the y-intercept. So let me try again now. -1/2. Down 1, left 2. Everybody all right? Down 1, left 2. You sure?
It's supposed to be going the other way.
Oh, this has got a negative slope, which we wrote yesterday means the line should go downhill. Why do I have an uphill line cracking?
I don't know why I did
Doing
that
it
either.
backwards.
What am I doing wrong?
You went down into the...
I went negative both ways. What's a negative by negative? Positive, good. So I can only go negative one of the ways. It doesn't matter which. I could go... Oh, shoot. I hate it when the marker does that. I'm going to do what Grace said. Down 1, right 2. That'll work. What if I wanted from my intercept good chase to go up? I could go up 1, left 2. Now I think we finally got it. Oh!
Maybe not.
Tell you what, we're going to run out of smartboard ink if that nonsense keeps happening.
That was a good line.
That was. So there, look at it.
How long ago asked for the ink?
Me too.
We need more smartboard ink.
It's about to run out. Those lines keep drawing up there like
You
that.
want me to go get some?
Please ask. I want to see what. I want to hear what she said.
I bet you could get Miss Amy going for a while with that. I bet you could.
If you sent me and him up there together, he'd have a hoot.
She'd probably be calling Office Depot and school supply stores and...
You got smartboard ink?
Like Coach Wright insisted that we come up here right now and get you some we need smartboard ink. Like, it's ridiculous. We can't even take notes. I'll jump right on it.
Wow, you think you're something, huh?
Like asking for blinkers.
Something more than you. What?
Alright, we moved on. This time the directions say find an equation of the line with a slope of 2/5. It goes through the points 3, -4, and write it in standard form. Oh no, we've dealt with slope-intercept form already, y equals mx plus b. Now all of a sudden we got something asking for standard form. That means my final answer's got to be in the form of ax plus by equals c. That's standard form. Okay, what about that 3, -4? Is that the b? Is that the y-intercept? No, it's not. Good. First period said it was. If I found that, it would be over 3 and down 4. That's not on the y-axis, is it?
Nope.
So I don't have a y-intercept in this case. I've got a slope, and I've got just some random point. There are 2 ways to work this. I'm going to show you both ways, and you can pick your favorite. Anybody remember when you've got a point and you've got a slope, what form you're meant to use?
Point slope.
Point slope form, because you've got a point and you got a slope. So Grace is right on the money. Point slope form says y minus y1 equals m times x minus x1. So we got our m. Here's your x1 and your y1. Okay, so we just got to substitute the stuff in. Y minus y1, so it's y minus -4, which is the same as y plus 4. M x minus x1. Now, if it had just said write an equation of the line, we've done that. But I was mean to you, and I tacked on there, put it in standard form.
Okay.
Okay.
I have a question.
Okay, I got an answer, maybe. If not, I'll
Is
ask
it
Caleb.
We added because it was the opposite. We did the opposite.
No, it was y minus -4, and when you subtract the negative, that's the same as adding.
Okay, I get it now.
You sure do.
Yeah.
Alright, we're ready to try to start getting this thing into standard form now. What would be a good idea to do? Okay, good, Caitlin, good, Grace. Distribute that 2/5.
Yep.
So it's going to get me y plus 4 is equal to 2/5 x minus 6/5. That a boy, sir, plunk it. Alright, standard form up there in the top right has the x and the y on the left side and the number without a letter on the right side. So we got to start doing like the bell ringer and moving stuff around. Say it again. Subtract 4. So what Grace is going to do first. Let's go there. I like it. Here it's going. Gives me y equals 2/5 x. Let me do some mental fractions here. This is 20/5, negative 6 minus 20. Caleb, negative 26/5. What's negative 6/5 minus 4? Huh?
What, negative 6/5 minus 4?
Uh-huh.
I got negative 14/5.
Hold on, did you type it in right?
Is he right? Am I wrong? He might be. I'm not saying I'm always right, but I think
Hold on.
negative 6 minus 20.
Calculator that.
What you
No, that's right.
What'd you type in?
6/5.
Negative 6. It's a negative 6.
Right.
That's your
Answer
baby.
right then.
There's another one there.
Yeah, that's it.
Oh.
Yeah, negative.
Alright, so we're good on that. Okay, I still don't have my x and my y on the same side together. Subtract the 2/5 x. Grace T is correct. That's going to give me right over here negative 2/5 x. I'm writing it first because the x comes first in standard form. Plus y is equal to negative 26/5. That's like the smallest I've ever written on that. I don't know why I did that. Okay.
How do you know where you're
It's a guess every day. I like that, but that's not technically in standard form. Standard form wants your a and your b to be integers. What does that mean? Take a hint. Good, I got fractions there, so it wants them integers, it wants them whole numbers. So what can I multiply that by to cancel out those fractions? 5, good. We multiply by whatever they'll go into. They'll go into 5. I can do even better than that because I'm a positive person and I like my a to be positive. I'm going to multiply by a negative 5. Okay, so right here we're going to distribute a negative 5 to this whole thing. 5 and the 5 cancel out. Negative times negative is positive. So I got 2x minus 5y. The 5 and the 5 cancel out. Negative times negative is positive equals 26. That is finally in standard form. That's how that problem, that's how they want you to do it, but I think that I got a better way. You can pick your favorite after I show you the other way. Okay, good. Then you'll do that every time. Everybody got what you need on that one?
Yes, ma'am.
Alright, same problem. Same problem. I got a slope of 2/5. And I got a point of 3, negative 4.
Okay.
I'm going to go, remember on the last problem we got to a point where it was in slope-intercept form? I think I can take this stuff and go straight to slope-intercept form.
This is what I like.
Good, Mason, I'm with you. So I got y equals m x plus b. Right? Now we can just algebraically solve that for b. 2/5 times 3 is 6/5. So negative 4 would equal 6/5 plus b. What would we do to get the b all by itself?
Get the numbers on the other side.
Subtract 6/5. Good job, Baylor.
Good job, Baylor.
So I think that's negative 20 minus, that's the same thing again, Caleb, negative 26/5 equals b. Okay, so if I wrote this now with my m and my b, I would have y equals mx plus b. Okay, so I'm already in slope-intercept form now, and I just got a couple more steps to get it to standard form. What would we need to do to get the standard form, to get the x's and the y's on the left side together?
Subtract 2/5 x.
Okay, good. We're going to subtract this 2/5 x from both sides, so it'll be negative 2/5 x plus y is equal to negative 26/5. That should look awful familiar to you. Good. Multiply it all by -5. So that gets me 2x minus 5y equals 26. So you got the exact same answer. Which one's better? Whichever one you're better at.
I'm better at
So it doesn't make a difference to me. They both work. They're both mathematically correct. I've got my preference, but it doesn't mean it's any better.
What's wrong with that?
Oh. He's a little, yeah, he's a little selfish, isn't he? Hey, I got an idea. Everybody done with that one?
Not yet.
Okay.
Baylor's head's in the way.
Oh, Baylor.
Hi, Baylor. Y'all can't be hating on me.
We don't. We're glad you're here. We had withdrawals when you were out a week.
Oh, Baylor, if you keep getting in my way.
You, Mason, put the ponytails back in your hair to stay your eyes.
No.
You watch him every time he rides, he just flick his hair out. Watch him. Come on, Mason. Yep, is that,
I got it done.
I got an idea. Let's just all get a haircut.
Yeah, for real.
Yeah, probably not.
You imagine if we cut the hair in this classroom alone,
Especially
how much
hers.
locks for love we could
We're
get?
talking about locks for love, though.
That's a lot.
Everybody's except for mine. Oh. It's mine ain't coming off.
Oh.
I'm going bald.
Okay, fine.
I'm actually thinking about cutting my hair. You going bald?
Alright, let's look at this. Shh. Hey,
Wouldn't he look so funny if he was bald?
I would
I swear he would.
I'm not being bald.
I don't necessarily think bald, Hayden, but I think we can cut your hair.
I think it's fine.
Nah, I think have you ever had short hair?
I think
can't
if you had
remember.
like Zane's short hair.
I can't remember.
I've had
Zane had long hair and he came back like that one day and I was like, whoa.
It was
I
like a
remember.
hat.
Yeah, it was like a hat. Little flip.
Yeah. Alright, we got here 2 points. Okay, it says find an equation of a line going through those points and write it in standard form. Now I want you to think about a line. Any line in general. Any line, I'm going to put an exception on it. Every line except for a vertical line has something major. What does every line have that a vertical line does not have? If they've all got a slope. Very good. Good, Zane. Good, good, good. So anytime you're told to write an equation for a line and you don't have a slope, you got to find the slope. Okay? So we got 2 points here. We know a good old slope formula. There's my x1, my y1, my x2, my y2. Let's go to town by the slope here. y2 minus y1 over x2 minus x1. -2/3. Is that what y'all got? Alright, so now we're in the same place that we were on the previous problem, except we even got more information. We got a slope now, and we got 2 points. On the previous problem, we just had 1 point. Does that matter? What do you think? Why I got 2 points? Do I really get a hot and a mess about it?
Nope.
No?
You do the same thing. You just
Good. So I'm just going to get to pick which point I want to work
Yeah.
with. Exactly right. Mason might pick the first point, and Baylor might pick the second point, and they're still going to get the same line. Okay, so it doesn't matter. All right? All right, so Hayden, which point do you want to use? The -2/6 or the 1/4? Okay, Mason's using the 1/4, so I'm going to circle. Hayden's using the 1/4, so I'm going to circle that. All right, Caitlin, do you want me to work this, putting it in point slope form or putting it in slope-intercept form? Slope-intercept, so that's what I'm going to do. And Michael, that's not what you like. I think it was you, but that's okay. We'll still get the same answer.
Let's right on.
Slope-intercept, y, that's Hayden's y, equals m, x, there's Hayden's x, plus b. We okay? -2/3 times 1 is just -2/3.
I have a question.
Yes, Mason Lambert.
Are we gonna have to do the opposite thing we're doing right now? In a minute? Like we have to find do the points. Or no?
Like they give you a line or something? Possibly. I haven't looked that far ahead yet. But it's a possibility. Yeah. Alright. We need to solve for the b now. So I got negative 2/3. We're going to add that, dude. That's 12/3 plus 2/3, 14/3. So b is 14/3. So I got a b, I got an m, y equals mx plus b. I forgot my x there with my 2/3. There we go. Squeeze that thing in. Alright, hey, trying to get this in standard form now. Good, Aaron. We're going to add 2/3 x and move it over there with its buddy y. So we're going to have 2/3 x plus y is equal to 14/3. Now here's another part where first period struggled. I asked them what they were going to multiply here, and I can't remember what it was we multiplied by on the last one, but that's what they said. Why is it going to be 3 though? Because that's our denominator, so that's what they'll go into evenly. They thought I don't know what's going on with that. They thought since we multiplied it by 2 or whatever, I think it was 5, wasn't it? Since we multiplied it by 5 one time, that's what we would multiply it by every time. It's whatever your denominator will go evenly into. So this one's 3, so I'm going to multiply the whole thing by 3. I don't have to do a negative because everything's already positive. So the 3's cancel out. I got 2x. Here I got 3y. Here I got the 3's cancel out, so a 14. Winner, chicken dinner. Wait a second. What do you know, Joe? Alright, we alright? We got a couple more. Let's focus. Let's go.
Let's do it.
I got... It says find an equation of a line passing through the point negative 8, 3 and parallel to the line 2x minus 3y equals 10. Alright, we just talked about when we write an equation of a line, we got to know a slope.
Yep.
I know a slope in this problem, I just got to hunt for it. Where am I going to find a slope in this? Chase is trying to do some mental math, and he's pretty close. That may even be it. I haven't done the mental math yet. What's he doing what's Chase trying to do here?
Put in.
Okay, we're going to put it in slope-intercept form, right? So whatever's in the m spot will be my x. So we're moving that 2 over. So I've got negative 3y equals negative 2x plus 10. Then we're dividing everything by negative 3. Negative by negative makes that a positive 2/3 and a negative 10/3. So there's our slope for that line. I need a line parallel to that. So what's my slope going to be if it's parallel? Same thing. Slopes, parallel lines have same slopes, right? So I've got a point here. I got a slope of 2/3. Point and a slope. So I could go to point slope form, or I could go to slope-intercept form. What do you want to do, Aaron? Slope-intercept. Y equals mx plus b. So 3 equals negative 16/3 plus b. Add your 16/3. That's 9 and 16, 25. B's 25/3. Is that right? Everybody checking me? Oh. Is that good? Alright, so I got a B. I got an M. Mason, pay attention. Y equals 2/3 x plus 25/3. What should we do here to get to standard form? Yeah, but not yet. I don't want to do that yet. What would I want to do first? Good. Let's go ahead and move that x over first. You would still get there, and I just like to try to do stuff in the same order so I don't confuse people, but you'd still get there. So I got negative 2/3 x plus y is equal to 25/3. Did you get that, Hayden? Now I'm ready to multiply, like Aaron said, a 3, and I can go even one better than that and make it a negative 3 since my a is a negative. Okay, so that gets me a positive 2x, a negative 3y equals a negative 25. So that line will be parallel to that one up there. Now, do you notice the one that I've got partially circled down there at the bottom? What's similar to it to the one that was parallel to? 2x plus 3y is the same. So if you're going to be parallel like that, your A and your B are going to be the same, but you still got to do the work to figure out your C, unfortunately. Okay? All right, not going to make us do one right now, but what if we wanted a perpendicular line to that? What would we have used in our M instead of 2/3?
Opposite reciprocal.
Which would have been what? Negative 3/2. Very good.
Any junior that ordered a class ring, please go to the library.
Should I pass that?
I don't know. Go ahead. I don't know how long it'll. So just got 15 minutes, but I don't know how long it'll take. Okay, so we could do that same drill there, but just use the opposite reciprocal if it asks for perpendicular, right? Might see that on an assignment or test. Everybody good on that?
Yes.
All right. Let's look at, we've been doing all things linear here all week. Let's look at all the forms of linear equations that we know. This is good note stuff right here. Y equals mx plus b. What's that one called? Hello?
Slope-Intercept.
Thank you, Mason. Kirsten. Slope-Intercept. When would be a good time to use this one?
We got
When we're trying to find the slope, or trying, what else? What could I have to plug in the very first problem we did today? The y-intercept. Remember I gave you that 0, negative 3. So if I've got a y-intercept, if I've got a slope, I'm looking here on that. What about y minus y1 equals m times x minus x1? What's this one called?
that.
Point slope.
Point slope. Hot dog. We got a point slope. When's a good time to use point slope form?
You got a point and you got a
When you
slope.
got a point and a slope. Okay, we talked today that maybe some of us don't like it even then, but that's when it would be a good time if you liked it. Okay, how about this dude? AX plus BY equals C. What's that called? Standard. Lots of times that's where people want you to end up. They want your final answer in standard form lots of times. But other than that, when would it be a good time when would I, this is a different type of question, when do I like stuff to be in standard form? I know you got to read my mind on this question. I'm sorry. I'm trying to think of better words. Think back to when we graphed these the other day. When I was finding the intercepts, x and y intercepts, all I got to do is plug zeros in on that. Very good, Chase. I'll spit your name out, Chase, in a minute. Try to change your name to Chance. That wouldn't be good. Oh, wouldn't be good. All right, how about if I had something that said y equals b? What kind of line's that? Oh, I stumped you. Horizontal, look at you. That's a horizontal line. And what's b there? It's the same that's in slope-intercept form. What's b?
That's the y-intercept.
It's the y-intercept. Very good. So when you see something that says y equals 7, that means you would go up to 7 and you would be aligned through that, right? Very good, very good. All right, how about x equals a? What we got on here? Got a vertical, good. Process of elimination, vertical. What is the a, any significance here? It's just where it crosses the x-axis. Very good, Aaron. Good job. All right. Let's find a good word problem to end on.
Word from.
Uh-huh. We like them. We're champion word problem solvers. If there was a contest, we would win a gold medal. All right, this one says, suppose there's a flat rate of 20 cents, so something's going to charge us 20 cents no matter what, plus a charge of 10 cents per minute, 10 cents per minute, to make a telephone call. Write an equation that gives the cost y for a call of X minutes. And by the way, y'all don't know about this because of cell phones, but this is how it really used to be.
Yeah.
It's craziness.
I think I know it.
All right, Mason, hit us.
I think it's y equals 10, or that 0.10x plus 0.20.
What do y'all think?
Yep.
Will this show us, so I could say, well, if I talked on the phone 10 minutes, how much would that cost me? What would I do to figure that out?
Add that,
Okay, so we would have, so what would that, Chase was right on that, because that's $1 plus 20, so if I talk on the phone 10 minutes, my phone bill's gonna show $1.20. Good job on that equation there, Mason. Everybody good with that? Good in the hood?
We do one of those for the thing.
Yep, you're gonna have an exit question in a momento, so let me get it posted.
One just like that.
One just like that.
Maybe the same one.